we're going to take another look at section 2.1 here, making sure that we have everything down. We're using this sheet again. Remember that this is going to be for 2.1a right here, and then on the back, really all of this stuff is going to be for 2.1b and also for 2.2. So here's the worksheet that we want to be looking at. Use the following information to find the exact 6 trig values. So I'm looking at finding all 6 trig values. And we're going to look at the second one here, just because I think the first one I think will be a little bit easier for us to figure out. So we have a secant equal to 2 and a cosecant that's negative, less than 0. So a secant that's equal to 2, that's positive, and I forgot what they were, secant positive and cosecant negative. So I go to my sheet, I'm looking for a secant that's positive, and that gets me here or here because I'm looking at the cosine value. Then I wanted the one that has a cosecant that's negative, so I'm looking at the y value then. The y value being negative means I'm dropping down to the 4th quadrant. So this is where my triangle is. I want to draw my triangle in there with the reference angle like that. So I have a triangle that comes down, whoop, and goes up like that. Here's my reference angle, the theta that I'm looking at. So the secant, again, some pieces of information if you were using the sheet. Secant value, wrong one, secant value here is equal to hypotenuse over the adjacent. So I can put in that this is hypotenuse over adjacent. So the hypotenuse over the adjacent to my theta value. Now that really gets me into a situation where I've got 2 sides. So if I want to find the third side of this, I can use the Pythagorean theorem. So I have 1 squared plus the side that I want to know. We'll call it b. B squared is equal to 2 squared. So this is 1 plus b squared equals 4. Subtract 1 from both sides. B squared equals 3. And so then b is equal to the square root of 3. Okay, so that's the triangle set up. Those are the things that I need. I have my theta value, so my sine value of this is the opposite over the hypotenuse. So opposites over here, so that's square root of 3 over 2. My cosine is adjacent over hypotenuse, which is 1 over 2. My tangent is opposite over adjacent. When I flip these things over, I get 2 over the square root of 3. I can't leave the square root of 3 in the bottom, so I multiply this by the square root of 3 on top and bottom. Secant, flip that over, I get 2 over 1. It should be the same as this. Okay, it should be the same as that. And then my cotangent is going to be 1 over the square root of 3. Can't leave the square root of 3 in the bottom, so I multiply by that on the top and bottom, and I end up with square root of 3 over 3. Now when I look at this, my secant matches up. My cosecant is not less than 0 though. So think about what happened here. Well, how did I end up with all positive values? Well, let's go back to this here. B squared is equal to 3. When I take the square root of that, I get a plus and minus square root of 3. This one is the minus square root of 3. Okay? So I want you to make sure that you're going through and you're looking at these, making sure that all of the parts satisfy that after you've gone through and done it. So this square root of 3, anywhere that there's a square root of 3 has to be a negative. And now my cosecant is less than 0. And so I'm good to go. So make sure that you're going through, doubling back, making sure, because we're going to end up making mistakes if you don't double check your work. Okay, so go back, make sure that that's actually the conditions that they gave you are the conditions that are satisfied. All right, so here's section 2.1b. We're simplifying the following. The approach that you want to take when you're going through and looking at these trig expressions is that you want to look and see first if there's really any factoring that you can do or adding or subtracting things that you can really do first before you change to sines and cosines. In this problem, I'm going to change everything to a sine and cosine. Secant is 1 over cosine theta. So then when I multiply those two things together, I get sine theta over cosine theta. Sine over cosine is tangent. Now I didn't give you answers to these. I will post an answer key so that you can go back and you can take a look. All right, you can see when to stop. I want to see where you think you can stop. So we worked on it where in the book you had some answers that you knew when to stop. I want to see now just kind of if you have an idea of when something actually is simplified. Now when we get down to tangent theta and there's nothing else you can really do, that's a simplified version of part A. Okay, and so we'll do one like f here. So I've got secant 1 over cosine times cosecant, which is 1 over sine, times cotangent, which is cosine over sine. Where did all those things come from? They come from here. Okay, so here's cotangent. We had secant and cosecant. So all of those things are right on the sheet. So they're available to you if you didn't remember them. So when I do that, when I multiply all these things, I've got a cosine over here and a cosine over here that reduce. Because all these things are multiplied, they're going to reduce just like fractions. So on the top, I've got 1. On the bottom, I've got sine squared, sine times sine. Well, that can't be the most simplified version because it's a fraction that can be turned into the sine's inverse, which is cosecant. So I can go one more step and turn that into cosecant squared theta. On the test and on the practice, when we get to the practice test, we'll give you the answers to these, okay, so you'll be able to see when you're actually finished with them. But this worksheet is gonna give us a good idea of whether you know when you should stop or when you shouldn't. So let's take a look at one of these fraction ones. Let's take a look at I here. So I've got sine theta, and then that's times secant theta. So times secant theta, secant is 1 over cosine. And then that's all divided by tangent, which is sine over cosine. Well, if I write it this way, it looks like a big jumbled mess, but on top, I can multiply these two things together. And so I can get sine theta over cosine theta. And then I'm just going to write that dividing by, like this, divided by sine theta, cosine theta. Well, if I think about it, I really could make a jump here to the answer right away, but if you can't make that jump yet, here's the extra step. I'm dividing by fractions, so I flip and multiply. Sines are going to cancel out, cosines are going to cancel out, and I end up with 1. So you could have made the jump that I'm taking something and dividing it by itself, sine theta divided by cosine theta, and I'm dividing that by sine theta divided by cosine theta. Okay, so when you make that jump, you could have eliminated that extra step in there, but that extra step is okay too. So then here's the back of that worksheet, a little bit more work that goes into it. We'll look at some of these trig identities here. In L, I've got 1 minus cosine squared. In 1 minus cosine squared has got to be one of those Pythagorean triples that comes to your mind that you look for to see if you can change it into something. You can look for that substitution. Okay? Now, I know some of you are going to be tempted to go through, and you're going to be tempted just to change the cosecant to 1 over sine, and some of you are going to be tempted to go through and use the distributive property, and those things are fine. You can do those. All right, there's no reason that you can't do those. But what ends up happening is that you end up making a longer problem. So anytime that we have this cosine squared or sine squared, we want to go back and we want to see if there's anything that we could substitute first. So I've got 1 minus cosine squared. All right, so when I come down to my Pythagorean triples here, I want to look for either 1 minus cosine squared over here, or 1 minus cosine squared in one of these three boxes. Well, I see that 1 minus cosine squared is actually equal to sine squared. These are going to be the most common ones that we use, 1 minus cosine squared and 1 minus sine squared. Okay, and so if you have that type of a situation, you should be looking for those things that we can substitute out. So 1 minus cosine squared is actually the sine squared. So when I go to L here, this is actually sine squared theta times cosecant, which I can, of course, still turn that into 1 over sine theta. Well, when I multiply these, I've got two sines on top. This is sine squared is this. And then I'm taking that times 1 on the bottom, 1 times sine theta. The sine thetas are going to cancel each other out, and I end up with just sine theta. There's nothing else that I can do for simplifying that problem. Okay, and so look for those things that we can factor out. Now, the problems here down at the bottom, when I look at OPQ, these look like problems that I may want to just jump in and try to change things to sines and cosines. But again, there's a faster way. If I look to try to factor these first, so if I've got something that can be factored, I want to try to factor it. So doesn't matter which one we look at, they're all about the same. So let's take a look at Q here. I've got cosine squared in both of these, so I'm going to factor out a cosine squared. When I do that, cosine squared divided by cosine squared is 1. Cosine squared tangent squared divided by cosine squared is just tangent squared. Now I've got a 1 plus tangent squared, but it makes me think that there might be a Pythagorean triple that I can substitute that for. Well, 1 plus tangent squared, I have a Pythagorean triple that says that 1 plus tangent squared actually is secant squared. So I can come down here and say that this is actually secant squared, whoops, times cosine squared. Secant squared, so I have cosine squared times secant squared is 1 over cosine squared. When I multiply those two things together, I get cosine squared over cosine squared, which is just 1, which can't be simplified anymore. Now remember, again, on the test, I'm gonna put equals 1. And so I want you to work with this left-hand side and just go through and figure out how that side is equal to 1. So you go through and do all the work, the same exact work that you have shown here, except for that you have an end goal in mind. Okay, so keep working on these. I'll post an answer key, but go through, try the problem. The only way to get good at them is to try them. Okay, keep working on them. Look for patterns. Look for things that are similar between fraction ones, similar between ones that have adding and subtracting, similar between sines and cosines, those types of things. Okay, and so go through, try them, and then double check your answers.